Okay, so welcome back to part 2. And our directions on this portion say, based on the given information, write a linear equation in scope-intercept form. So our first equation, if we're writing in scope-intercept form, or y equals m times x plus b, is going to be y equals, okay, my m is -2 times x plus 3. Okay, the next problem that we have has a scope that is equal to 0 and a y-intercept that is at -1. Now, what I'm going to do, I'm going to go ahead and plug this into our regular y equals mx plus b equation. So y equals 0 times x minus 1. Now, here's the interesting thing about this. What's 0 times x? We know that's 0, right? And 0 minus 1 is -1. So y equals -1. Okay, so on I, we have a point for the y-intercept that's going through the origin itself. It's going through the very center of the graph. Okay, so y equals mx plus b again. So y equals 1/2 x plus 0. Well, in this case, we could even simplify that down to y equals 1/2 x, because adding 0 to that does not change the value. We just need to remember that if we were going to graph this, it's going through a y-intercept of 0 because we don't see that value there. Our last one is an undefined scope, and it goes through the point 3, 4. Now, if you remember, undefined scope means that it is a vertical graph. And this is going through the point 3 and up 4. So if it is a vertical line going through 3, 4, no matter what the y equals, x has to equal 3. So that is actually our equation. X equals 3. This is the one equation that we cannot put in y equals mx plus b form because the x is all there is. Everything else, the y's, it doesn't matter what y equals, x has to equal 3. Okay? So that's kind of an interesting situation. It's one that doesn't come up real often, but it's one that when we do see it, we have to be aware of what to do. All right, now, this last part, we've got several examples. I'm just going to do a couple of them for you because I think that if I do all of these, it's going to kind of be too much for you. But I'm going to do a couple. We're supposed to write the equation in point scope form and then change it to scope intercept. Okay, so first thing, writing in point scope. We know that's y equals m times x minus h plus k. All right? Now, that's going to give us y equals 1/4 x, okay, minus the h, so minus -4. If I have minus -4, that's going to be the same as plus 4. And then plus 2. Okay, now that we have that, we need to change it to, and that is our point scope, but we need to change it to scope intercept. Okay, so first thing, we're going to go back to our old friend, the distributive property. So y equals, I'm going to multiply that negative 1/4 times the x and times the 4. So that's negative 1/4 x minus 1. And I'm going to go ahead and add the 2 now that I've distributed that. Okay, so y equals negative 1/4 x, and minus 1 plus 2 is going to be plus 1. Okay, and that is my slope intercept. Or, yeah. Okay, the next three problems are exactly the same type of problem. But when we get down to O, they've given us 2 points. And they want us to do the same thing, put the equation in y equals m times x minus h plus k form, point slope. The only thing is we don't know what the slope is yet. We do remember, however, that at the very top of the previous page, it gave us the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That is going to equal 2 minus negative 2 over negative 3 minus 3. Okay, so 2 minus negative 2 over negative 3 minus 3. That gives us 4 over negative 6, which is equal to negative 2 over 3. That's our slope. Okay, the next thing that I'm going to do is I'm going to use that slope in my point slope form, okay? So y equals the m, negative 2/3, times x minus h. Okay, now here's the thing. I could use either the negative 3/2 or the 3 negative 2. Either one would be fine. I'm going to use this negative 3/2 in this example, but I could have gone with the 3 negative 2. Okay, so minus a negative 3 would be plus 3, and then plus 2. Next, now that I've written a point slope form, I need to convert it to slope intercept. So again, I'm going to distribute that negative 2/3 across, okay? Our old friend, the distributive property. So y equals negative 2/3 x minus 6/3 plus 2. Okay, now 6/3, we can simplify that. It's going to give us y equals negative 2/3 x. 6/3 would actually be negative 2 plus 2. And if I take the negative 2 and add 2 to that, then those will cancel out. So I'm left with y equals negative 2/3 x as my slope intercept. Okay, guys, I hope that this helps. And if you have any other questions, feel free to email me. I'll get back to you as soon as I can.